Good morning. I wanted to make this title as clear as possible. So this is really about understanding, and I hope that's easy to understand. And I hope I'll be easy to understand during the time I'm talking about this. I'm going to try and say the words objects and metadata as much as possible. We talked mostly about the audio objects and metadata so far. I think the next obvious question from the talk we just seen is, where does the metadata come from and how is it used? And oh look, the slides are advancing by themselves. So if you want to put the listener at the center of the reproduction is going to involve not just the audio objects, but also devices, environments, people, all of which will have their own requirements, their own metadata, you might say. So if multiple listeners at the same time all want to be at the center of the reproduction, that's a bit of a challenge. But all these people will have different requirements in the scenario, the devices will have different characteristics, and it's these things that feed back into the rendering process to create the audio experience. So this talk will focus on the renderer and what the renderer is doing and how it will do it. So in the production environment, you will have the writing, the performance, the recording, the mixing, mastering, and authoring, all of which will create audio objects and associated metadata to go into the renderer. But the renderer, in order to actually adapt to something else, will require some more inputs. So I'm also considering, and whilst it might not be politically correct to say so, objectifying the listener. So turn the listener into an object that has their own metadata and how that interacts with the audio metadata. For example, as a listener, does my preference for language and accent match the performer of the program? Probably not. How is my hearing? Where am I in the room? What devices are close to me? So the devices have metadata such as their frequency response, their distortion characteristics, of nonlinearities, directionality, so on and so on. And the environment is effectively an object. If you're watching a program on television in a room and you pick up your phone and walk to a different room, the environment and device have changed, but you're the same, and the audio is the same, but the renderer will take all these things and create a new experience for you. And for it to be extendable, we also have other metadata that will surely be added in time. But just to boil down the whole project, think of everything as an object with metadata. To do this really involves understanding this mapping between the parameter space of the system and the psychological space in which we perceive the system. And this is not easy to do. So if you create a system output, we have the impression of the system output, but we also have our impression of what we want the system out to appear like. And really what we want to do is minimize that distance in the parameter space. So that mapping is different for every listener object, is different in different environmental objects with different device objects. It's also not a one-to-one mapping. So understanding this connection is why we have to do so many perceptual tests and why perception and listener-centric concepts are at the core of the S3A project. I'll talk briefly about a few of these. So in a paper here from 2016, just asking people to listen to sounds and categorize them. Very, very brief summary is that dialogue is treated slightly separately or understood slightly separately to these other of the sounds. And of course, we have this connection to the human voice that when we hear it, it has more meaning than a few other things. We often see in mixing then that the dialogue, narration, these human voices are louder than other elements. So we've done a few mixing experiments, perhaps the most ambitious of which was done in a car. I'll talk more about that this afternoon, where we ask either very experienced or even inexperienced content creators and listeners to have a tactile experiment where they can adjust levels themselves. So let's say we give them control over a few faders. We ask them to recreate the ideal, to tailor the system close to their ideal. And then we can use that to inform what the renderer will do, because having this intelligent style rendering or this informed rendering requires rule sets and information to inform it. We need to gather these from experiment. Throughout the project, we've also tried to incorporate some new perceptual evaluation concepts or clarify them a little bit. So for example, an experiment where we ask people to compare two different sounds and give a list of attributes, and they can check all attributes which apply to their understanding of the scene, of the system. We also tried to look a bit further at a test methodology which I think matches very well the diagram I showed. So this is the ideal profile method, where in addition to rating real systems, you also have to give an idea of what your ideal is, because that will change for different listener objects in different other environments. So as an overall summary, a listener-centric object-based production/reproduction, taking the word audio out of it, will involve some audio objects with their metadata, but also other objects with metadata, and these are all conceptually similar. The non-audio objects can be considered contextual, situational, potentially even semantic. Semantic means meaning. What does meaning mean? Hopefully we'll get onto that in the next few talks. So thank you very much. The next slide will have some papers that have had some relevant information. Other than that, that'll be that.